we've covered addition of radicals, we've covered multiplication of radicals. What we haven't talked about is division of radicals. And this gets into a topic that, in one sense, it's no harder than multiplication, because if you can multiply two numbers together, then division rules work the same. But there's another aspect about rationalizing radicals that gets complicated, and it's kind of just our own fault, because there's a grammar to this that you have to understand. There's a proper way to write radicals, and there's an improper way. And the improper way is this: when you have a radical, a square root of something on the bottom of a fraction, the process of rationalizing, right, this word right here, to rationalize a radical means to rewrite it in such a way that it's still the same value, it hasn't changed its value, but it doesn't have a square root on the bottom. We don't like square roots on the bottom. Well, I don't really mean we. I don't care. But mathematicians don't like it, so we all have to learn how to change it. So when you see something that says simplify a radical expression and it shows a square root in the bottom, that's what it's getting at. You have to rationalize these things. So here's how we go. The square root of 11 fifths equals the square root of 11 over the square root of 5. Okay, that should not surprise us from what we learned about multiplication. But we still have to deal with this radical 5 thing. And here's where I want to introduce this concept, which hopefully is not new to you, but maybe it is, of a crazy 1. I think everyone would agree that if I multiply this fraction by 1, it's not going to change its value. Okay, so instead of writing 1, I'm going to write something else, and it's going to look a little crazy. Radical 5 over radical 5. That's still equal to 1, right? But watch what happens as we do this multiplication. We get radical 55 on top. And what's radical 5 over times radical 5? Well, that's radical 25, which people should recognize very quickly is really just the number 5. So this is our answer. I would love to simplify the top, that radical 55, but I can't. There's no square root in it that we could pull out. So this is our final answer, root 55 over 5. And you see, now I don't have any square roots on the bottom. It is called a rationalized radical. So, next one. 10 over radical 5, just like in the last example, I'm going to multiply by a crazy 1, which is radical 5 over radical 5. So this becomes 10 radical 5 over 5. Now, unlike that last example, I can actually simplify this, right? I can, what's 10 divided by 5? That's just equal to 2. So this is 2 radical 5. And you have to write it in simplified form. Most of these problems will mark you wrong if you don't simplify it all the way. Okay, so there's the answer to that one. And this next one is going to start getting a little more difficult. I need something that is going to get rid of the radical sign there. So let's think about what this is for a moment before we decide on what crazy 1 we want. This is 6 over the square root of x times x times x. And if I want to take the square root of something, remember what we're looking for. We're looking for pairs. So here's a pair. But I want one more pair, and I don't have it yet. Wouldn't it be great if I had another x in that thing? So what we're going to do is use a crazy 1 to give it another x. I'm going to give it square root of x over square root of x. And now I have 6 square root x on the top. And see this guy? That becomes the 4th x right here. So I now have 4 x's on the bottom. That's 2 pairs, so I can pull out an x times an x. Okay, which rewritten is 6 square root x over x squared. That is how you would write this guy. And in the last example, it really does get very messy. This is just to run you through your paces and make sure you understand the concepts. So I have xy divided by this 6th root of 2 times x to the 5th times y cubed. Now, using that concept from the last one, where the square root wants pairs, the 6th root wants 6 of a kind. So what do I have to multiply by to get 6 of a kind? Let's worry about the denominator. Don't worry about the numerator yet. We'll get to that. So I only have 1, 2. I'm going to need 5 more 2's. And then I'll have 6 2's total, which gives me 6 of a kind, and I can pull that out of the square root. And I currently have 5 x's, so I only need 1 more x. And I have 3 y's, so I need 3 more y's. And whatever you do on the bottom, you have to do it on the top also, because this is, after all, just equal to 1 right here. This thing we're introducing. So what does this become? We're going to have to take another line here. This becomes xy times 2 to the 5th xy cubed in a 6th root, forgot that earlier, divided by the 6th root of 2 to the 6th power, that's just 2. The 6th root of x to the 6th power is x. The 6th root of y to the 6th power is y. And now we can cross some things out. That's nice. So the x and the y cross out, and we get this. We get the 6th root of 2 to the 5th is 32, so I'll just write that. 32x y cubed, all divided by 2. And that is the form of that ugly, ugly final answer.